The HAARP antenna arrays. HAARP is to bounce a signal off an asteroid in a new NASA experiment. HAARP will transmit a continually chirping signal to asteroid 2010 XC15 at slightly above and below 9.6 megahertz, that's 9.6 million times per second. University of Alaska Fairbanks. Now, an experiment that to bounce a radio signal off an asteroid on December 27, that's 2 days ago, to serve as a test for probing a larger asteroid that in 2029 will pass closer to Earth than the many geostationary satellites that orbit our planet. The High Frequency Active Auroral Research Program, HAARP for short, the site in Gacona will transmit radio signals to asteroid 2010 XC15, which could be about 500 feet across. The University of New Mexico Long Wavelength Array near Socorro, New Mexico, and the Owens Valley Radio Observatory Long Wavelength Array near Bishop, California, will receive the signal. This will be the first use of HAARP to probe an asteroid. What's new and what we're trying to do is probe asteroid interiors with long wavelength radars and radio telescopes on the ground. This is what Mark Haynes said. He's the lead investigator on the project and a radar systems engineer at NASA's Jet Propulsion Laboratory in Southern California. Longer wavelengths can penetrate the interior of an object much better than the radio wavelengths used for communication, he said, and knowing more about an asteroid's interior, especially of an asteroid large enough to cause major damage on Earth, is important for determining how to defend against it. If you know the distribution of mass, you can make an impactor more effective because you'll know where to hit the asteroid a little better, Hayden said. Many programs exist to quickly detect asteroids, determine their orbit and shape, and image their surface, either with optical telescopes or planetary radar of the Deep Space Network, NASA's network of large and highly sensitive radio antennas in California, Spain, and Australia. Those radar imaging programs use signals of short wavelengths which bounce off the surface and provide high-quality external images but do not penetrate an object. HAARP will transmit a continually chirping signal to asteroid 210 XC15 at slightly above and below 9.6 megahertz. That's 9.6 million times per second. The chirp will repeat at 2-second intervals. Distance will be a challenge, Haynes said, because the asteroid will be twice as far from Earth as the Moon is. The University of Alaska Fairbanks operates HAARP under an agreement with Air Force, which developed and owned HAARP, but transferred the research instruments to UAF in August 2015. University of Alaska Fairbanks, that is. The test on 2010 XC15 is yet another step towards the globally anticipated 2029 encounter with the asteroid APOPHIS. So that's what they want to measure. That's what they want to get ready for, the asteroid APOPHIS, which is huge. Now, it follows tests in January and October in which the Moon was the target of HAARP signal bounce. APOPHIS was discovered in 2004 and will make its closest approach to our Earth April 13, 2029, when it comes within 20,000 miles. Geostationary satellites orbit Earth at about 23,000 miles, so it's going to be coming in pretty close to our Earth, closer to us than our geostationary satellites. The asteroid, which NASA estimates to be about 1,100 feet across, was initially thought to pose a risk to Earth in 2060 for the passage that it will be making again in 2068, but its orbit has since been better projected by researchers. The test on 2010 XC15 and the 2029 APOPHIS encounter are of general interest to scientists who study near-Earth objects, but planetary defense is also a key research driver. Haynes says the more time there is before a potential impact, the more options there are to try to deflect it. NASA says an automobile-sized asteroid hits Earth's atmosphere about once a year, creating a fireball burning up before reaching the surface. About every 2,000 years, a meteorite the size of a football field hits Earth, that can cause a lot of damage. And as for wiping out civilization, NASA says an object large enough to do that strikes the planet once every few million years. NASA's first successful redirect an asteroid September 26, when its double asteroid redirect test mission DART collided with Dimorphos. That asteroid is an orbiting moonlet of the larger Didymos asteroid. The DART collision altered the moonlet's orbit time by 32 minutes. The December 27 test could reveal great potential for the use of asteroid sensing by long wavelength radio signals. Approximately 80 known near-Earth asteroids passed between the Moon and the Earth in 2019, most of them small, and discovered near closest approach. If we can get the ground-based system up and running, then that will give us a lot of chances to try to do interior sensing of these objects, Haynes said. The National Science Foundation is funding the work through its award to the Geophysical Institute for establishing the Sub-Auroral Geophysical Observatory for Space Physics and Radio Science in Gakona. HAARP is excited to partner with NASA and JPL to advance our knowledge of near-Earth objects, said Jessica Matthews, HAARP's program manager. And this is by University of Alaska Fairbanks Rod Boyce image, and this is on Bended Reality. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.